Hello, today we are going to solve this LeetCode problem 445. Okay, so add two numbers sequence 2. So for this problem, let's read this problem. You are given two non-empty linked lists representing two non-negative integers. The most significant digit come first, and each of their nodes contains a single digit. It's talking about here. This is the most significant digit come from the first, and then each of their nodes contains a single digit. So it's not like 12 or 14, it's only single one digit. Add the two numbers and return the sum as a linked list. So add this linked list with this linked list with the single digit, and we return this single list. This what the problem talking about. So you may assume two numbers do not contain any leading number except the number 0 itself. So it's talking about we assume the two numbers not contain any leading 0 here. Okay, so let's say this example, the least significant digit here, 3, 4 is 7, 4, 6 is 0, and then the carry is 1, and 2, 5 plus carry 1 is equals to 8, and then here is 7. Yeah, this is basically the problem. Okay, so how do we solve this problem? Okay, so first we need to travel the linked list backward. So because we are calculating the least significant one and backward, something like that. So how do we do this way? How do we do it? So we can actually do recursion. We can use a recursion, just go this way, and then backward. Okay. So when we use recursion, we can we actually using the implicit stack. Okay. So also we can use two stack. Okay, we use two stack. So we use two stack is explicit stack. Okay. So how do we do that? So there's some step. So first we push every element to the stack. Okay. Okay, let me just do this. So we push every element to step and then pop from the stack at the same time, and then we compute the sum carry. Also need a pointer result to restore the result. So how do we do? So let's say here, let's do this push to the stack. So first we push 7 to the stack 1. Here's the 7. Okay, and then we push the second one is 2. Okay. And then we push 4. And then we push 3. Okay, this is stack 1. Now the stack 1. We can do the similarly. We do the stack 2. Here is 5. We push 5. And the 6. And then 4. Okay, this is stack 1. This is stack 2. So we pop from the stack at the same time. So this one we pop 3, and the stack 2 we pop 4. So stack 3 and stack 4. So what's the digit number? So what's the sum? The sum and the carry. Also, when we calculate the digit equals to sum modulo 10, and the carry equals to sum divide 10. Okay, so for this one, 3 and 4, the sum is 7. Okay, the carry for the after this sum is 0. Okay, and then we continue pop. This one we pop 4. This one we pop 6. So it's gonna be 10. So the sum is gonna be 10, but we just need the digit of the sum is 0, and then the carry is gonna be 1. Okay, yeah, and when we do the 4 and the 6, it's 10. We also plus the carry with the previous sum, so it's 0, so still is 10, so it's something like this. And then we continuously pop. We pop 2, and here we pop 5. 2 and 5 is 7, and plus this carry is 8. So the sum of this digit is 8, and the carry for this digit is 0. And then we continually pop from here is 7, but here is already empty. When we do empty, we put a 0 here. So 7 plus 0 is 7, and the plus carry on 0 is still 7. So the sum for this digit is 7. And then what we return 70A7. Okay, this is a result. This is a result when we're trying to do this. But when we actually return the linked list, we return from this digit to this digit is 7807. Why? Because the first digit we got a 7. We have a result. We will know something like a result, and then we insert the second digit 0 to in front of 7, and the 8 in front of the 2, and we insert a 7 in front of the 8. So the result gonna be 7807. Yeah. This is basically this example. Okay, how do we use the 2-stack to solve this problem? Here. Okay, so use recursion or stack. So which one is better? In this case, I think we use the stack is better because use a stack. There's no limitation of running out of space. If we reach the maximum of the recursion stack. Okay, so using stack is better because there's no limitation of running out of space if reach the maximum of the recursion stack. So yeah, kind of like this. Okay, this is basically the algorithm for this problem. The time complexity for this problem is gonna be O M plus N. M and plus N is kind of the size of the stack, and also space complexity is gonna be O M plus N. Yeah, because we use 2-stack. Actually, this one is yeah, is maximum. This is maximum of M N. Okay, basically this is a problem. Okay, let's code. Let's do coding. Here we need to mention about here the space complexity gonna be O M. Okay, M actually is the maximum M or N, so we just do that way. So and here is the same. So O M or N, the one is larger. So maximum. Okay, this is the time complexity and the space complexity. Let's start coding. So for this problem, let's start code this way. So first, what we do, we create a stack. We iterate all the linked list, the element from the linked list, push it to the stack. stack of integer s1 and equals this value. This is stack for the first linked list, and then we iterate. Yeah, this is the first stack, and we iterate. We push every single value from the linked list to the stack, and similarly we do the stack 2. Integer s2, the value is new stack. Okay, and then we do a while loop. We push every single nodes from the L2 if it's not equals to none, and then we start push. We do s2 dot add s2 dot value to the stack, and then s2 equals to s2 dot value. That's the next one. Next. Okay, so here is next. So we put a next value to the L2. So basically, we put the 2 to the stack, push all the value to the stack, and then we do the integer sum equals to 0, and we new a link list node result. Okay, here is new list node 0. So we do this because we're gonna restore our result to this list node. Okay, and then we do while loop. So we will check if s1 is empty, or s2 is empty. And then if s1 if s1 is not empty, then what we do, we just sum we just pop the first element from the stack 1, and we add it to the sum, and then we do the second one. And then we pop the element from the second stack, and then we add it to the sum. And then after we add it, and what we do with our value equals to sum modulo 10. So this is a carry, okay? And then we new list node head equals to new list node sum 10, and then head next the result, and result equals to head and the sum equals to 10. So we do this one because we are trying to get a the carry here. So first here the carry initially is 0, and we a new list node is called a result, and we check the S1 is empty or not, or this one is empty or not, and then we do this. We do the modulo to the rest value, something like a 3 plus 4 is a 7, right? And then 7 is a result. And then what we do, here we knew another list is called head. So this is a sum divided by 10, and then we put that one is the head, that's the carry. And then what we do, we just the carry.next pointer to the result equals to here, okay, and then the head equals to the result, okay, and then do this one, and then this one. So and then we save this carry in the sum. We do the while loop again, because initially sum is 0, but we have to continue keep the carry. We do the another iteration, another kind of the loop, while loop, and we do this way, okay. Yeah, and then after this, what we do, we just return the result of value. If result of value equals to 0, then in this case we return the result.next. Otherwise, we return the result. Then 99, select 99 plus 1. So so this is example. I'm trying to give an example. So when the result of value equals to 0, that means this is the result. The value if equals to 0, that means the carry is equals to 0. If equals to 0, we just return result.next. Result.next is here, so we just return start from here to here. If it's not 0, if it's 1, then we return here, because here result here is 1. This is the carry, so we return here. This is kind of for this one, like for example, we do 99 plus 1 is equals to 100. So this one is gonna be the result of value. Here is equals to 1, so we return the result. But if here is 0, the carry is 0, then we just return the result next. Okay, let's run this code. Okay, let's do this one. The 21 says that oh, here is not S2, it's L2. Sorry about that. This typo. Okay, here is let's run again. Okay, it's accept. Let's submit the code. Okay, our code is faster than 16% for the Java Online submission for this problem. Okay, thank you for watching. I'll see you next time.